Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Thank you everybody for staying with me for another session of Computer Architecture Organization with Chapter 7 for this week under Computational Paradigm. So for Chapter 7, I only have one video for Chapter 7. So hopefully we can uh, start it immediately and you can proceed with your lab task later on. So thank you for your subscribe and your likes. So hopefully I can continue this up until the last chapter, which is chapter 8. So currently we have a lot of problems here in the university related to flooding. So I have to do this at my home with limited tools. So in case there are any problems with the video, I apologize. I try my best to give you the most suitable experience for our class. So, without further ado, we go towards our chapter 7, Computational Paradigm. And under Computational Paradigm here, okay, let's start with the first slide. So, we discuss about how the processor and register is organized, the instruction cycle and instruction pipeline involved inside your PC. So basically, inside your processor, we have three main things. So the first one is what we call an ALU, Arithmetic Logic Unit, which involve in performing calculation and comparison. And later on is the control unit, which performs the fetch and execute cycle. So means that it's either move data to and from the CPU registers or any other hardware components. And it accesses program instruction and issue commands to the ALU. So other than that, okay, inside the control unit itself, there are memory management unit, which supervise the fetching of instruction and data from your memory. And we have another one is the I/O interface, which sometimes combined with the memory management unit as bus interface unit. So basically, okay, with the inside the CPU, the most important component inside the CPU is the register. Without the register, your CPU will not work. So example of the register that we have in the CPU is the program counter, which is what we call short form as PC, or instruction pointer, which determines the next instruction for execution. So imagine that this is your CPU. Okay, we have this one as your CPU. Okay, and this one is your memory. So this memory involve in your PCs involve your random access memory, your RAM. So the control unit and program counter is as one unit, and other than that is the I/O interface and the ALU. So if you want to think of your computer, okay, you can think of the control unit as a seller at a McDonald's, for example. So this is McDonald's counter staff, okay, and here is the input-output interface, where is the counter, and here is the number of orders. And here is where you calculate the price for your order. Okay, and at the back here is your food. Okay, so the control unit basically it interacts with you, asks you, okay, what do you want to eat and everything, and give you the bills, which calculated from ALU, and also give you the data, which taken from the memory. So the program counter is the number that you get. For example, you are the client number 5. So when your food is ready, number 5, please come to the counter. So this is what happened within your processor. So an internal view of your processor, okay, basically look like this. So you have an ALU, register control unit, and if you go into details, okay, the control unit is the one that controls the bus inside your CPU. And the bus is where data coming in, either address data or real data or control data coming in into your CPU. So control unit will be involved in wiring and allowing access of data towards the arithmetic logic unit and also the register. So arithmetic and logic unit, basically they do all the computation. Control unit is the one that instruct the movement of data in and out of the processor for operating the ALU, and the register is a set of storage location basically. So inside CPU, what in CPU has to do Okay, there are only 5 things that CPU need to do. So those 5 things is repeatedly conducted most of the time and at extreme speed. So that's why your PC seems to be doing a lot of things at one time, basically. So the 5 things are fetch instruction, interpret instruction, fetch data, process data, and write data. So fetch instruction, the processor reads an instruction from the main memory. Okay, it doesn't necessarily be main memory, it can be in register or cache. So and then we have interpret instruction where the instruction is decoded to determine what action is required. And then we have fetch data. The execution of an instruction may require reading data from memory or an IO module. Process data, which the execution of an instruction may require performing some arithmetic or logical operation on data. And finally, write data. The result of an execution may require writing data to memory or an IO module. So it seems difficult. Okay, so let me uh, create a metaphor for these things. So basically, to start with a story, what the CPU has to do is similar like what you are going to cook. Okay, you as a person who likes cooking, who like to cook. So if you think about cooking as a CPU processing a data, so fetch instruction is where you get the recipe book, and then interpret instruction is where you read the recipe book, analyze the steps that you have to take, okay, what things you have to buy from the recipe book, and then we go to a fetch data which you get the ingredients, whether you have to go towards the supermarket or you find out within your fridge. So fetch data is like for you to get an ingredient. So process data is you cook the ingredients that you have. And finally, write data is when your cooking is ready, you want to serve or you want to store it inside your refrigerator or anything you need to do. So this is where you turn into write data. So fetch instruction is get the recipe book. Interpret instruction is read the recipe book, analyze what you need and what you have to do. Fetch data is get the ingredients. Process data is cooking. Write data is serve your dishes. Okay, so this is an easy things for you to understand what CPU doing inside your PC. So in terms of instruction, okay, instruction is one is the most important thing inside your PC. So instruction basically comes from your operating system. And when you want to deal with instruction, okay, firstly you need to know where to look at it. So CPU will fetch the instruction among the instruction library that it has from your OS. So the fetch read the next instruction from memory to the into the processor, and then when it decode or execute means that it interpret the opcode and perform the indicated operation. So if you say about interrupt, what interrupt is, last time we have discussed about interrupt. So if interrupt are enabled and an interrupt has occurred, save the current process state and service the interrupt. So this is one things that the CPU do. And then we have indirect, which sometimes a request for additional memory accesses, which is usually involve indirect addressing. So if you look at the instruction cycle here, okay, we have starting with instruction fetch here, okay, and then you have instruction operation decoding, okay, operand address calculation, operand fetch, data operation, and then operand address calculation, operand store, interrupt check, and then interrupt. So these are the instruction cycle that we have inside your PC, inside your CPU. Sorry. So if you talk about PC in this term, we are going to use it as a program counter. Okay, so inside your CPU, we have what we call a PC called program counter. We have IR called also known as instruction register. We have MAR also known as memory address register, and we have MBR known as memory buffer register. So the PC program counter contains the address of the next instruction to be fetched. So this address is usually moved to the memory address register and placed on the address bus. So this one is you look at from the program counter, you have an address put inside the address bus. And then from there, the control unit will request a memory read according to the address that you have put into the address bus. So when the control unit asks from the memory, you want to read from this address at the top. Okay, the memory will read the control instruction and then read the address, and it will respond back the data onto the data bus. Okay, and from the data bus it goes toward the memory buffer register, and then it moves towards instruction register. So here is where your program counter get the instruction for execute. Okay, for execution of your program. Okay, so next the PC is incremented by 1, means that okay, first instruction is received, now proceed to the next instruction. Okay, so this is what happens inside your PC. Okay, so now in case we have an interrupt, okay, in case your CPU has an interrupt and is doing a thing, okay, what does your CPU do? So the contents of the program counter, when the interrupt happen, they are firstly transferred to the memory buffer register. Okay, so memory buffer register is the one that involved in writing things inside the main memory. So the special memory location is reserved for this interrupt purpose. Okay, and here in this case, the data from the memory buffer register is inserted into the data bus. Control unit, since it's already know that it's an interrupt happening, it will instruct the memory address register to give access to the address inside the main memory for interrupt processing. Okay, so when this occurred, control unit also give instruction to the control bus telling the main memory we have data coming in due to interrupt, and the data flowing in. Okay, and then the memory will tell the control unit will tell the memory to write the data inside the interrupt memory location within the main memory. Okay, so once it's proceed, it already saved the data first. Control unit will instruct to the program counter, okay, now we are ready to process the interrupt. You can proceed with your next task as to process the interrupt. Okay, so this is what happened with interrupt cycle. So we have other like decode and execute cycle. So decode and execute is basically depend, okay, on the various machine instruction in the instruction register. So if it's involved processing with the ALU or getting something from the IO, okay, so there's a lot of process involved. If it's involving ALU, it's just put the data inside the ALU, process the data, and save the data again inside the register. So it's the direct instruction process. So then we have what we call the instruction pipelining. So instruction pipelining is what we do inside your PC, what your PC do to you, and it's a kind of algorithm used to speed up the processor execution. So pipelining involves breaking up the instruction cycle into a number of separate stages that occur in sequences. Okay, you remember the 5 things that I mentioned before: fetch instruction, decode instruction, fetch data, okay, process data, and write data. So all of those, okay, as a one instruction cycle, they will split them into a several stages. Basically, if you say that what I mentioned before, 5, we can be 5, or it can be even more. Okay, usually a lot of separation means that a lot more software, a lot more instruction can be processed at one time. Okay, so it's like manufacturing assembly line. Okay, like for example, if you look at how a company built a big car company, automotive company built a car. So they don't build a car one by one. After they finish one car, they go with another car. No, they will build a chassis first. Once the chassis team finish processing the chassis, and then they proceed to the door. Okay, door team. The door team putting on the door means that the chassis team is not occupied at all right now. So the chassis team will proceed with the second car, even though the first car is not finished yet. So this is the same theory where you have multiple teams processing. One that team already finished his task, it will move to another team, and the first team, okay, will continue with the second project. So this is what happened with the instruction pipelining. So basically, they split the instruction into several set of execution things. Okay, so here in this case there are 3 instruction execution, and at the bottom here we have 6. It can be 6, it can be 3, depending on the technology itself. And in case we have, like for example, 6, we have fetch instruction, decode instruction, calculate operands, fetch operands, execute instructions, and write operand. We have these 6 stages, and if we look at how they are being processed, so here we look at the team FI, fetch instruction, is doing the first instruction. Okay, and this is the time. Okay, time, unit of time. So 1 second, 2 second, 3 second, maybe microsecond. Okay, depend on the speed of the process itself. So in unit of time, instruction 1 coming in into the PC, fetch instruction will do the task first. And then after that, the instruction 1 will be forward into decode instruction, and then forward to the next team. While it's sent into the next team, the fetch instruction team is already not occupied, so it will move forward towards the second instruction. Okay, if they have to wait up until the whole instruction to finish first, means that they will waste a lot of time waiting for the first instruction to finish before proceeding to the next instruction. So this kind of time wasting, so that's why we use pipelining, where we can immediately pull the next instruction to the non-occupied team as soon as possible. So all instruction in this case, okay, for the pipelining to work, you need to have some certain assumption that all instructions are equal in duration. Each instruction goes through all 6 stages of the pipeline. You cannot skip any of the stages. Okay, and all of the stages can be performed in parallel, and there are no memory conflict involved when there are a lot of instructions being processed at the same time. So this is what we need to make sure in order to make pipelining works in speeding up your PC. So the advantage of pipelining is basically the cycle time of the processor is reduced by increasing the instruction throughput within your CPU. Means that you can squeeze more instruction at one time inside your CPU. The faster instruction being completed, the faster you feel that your PC is moving. So if pipelining is used, the CPU arithmetic logic unit can be designed faster to accommodate all those instructions. However, we have also disadvantages for the pipelining. The design of a non-pipeline processor simpler and cheaper to manufacture. However, non-pipeline processor executes only a single instruction at a time. In pipeline processor, insertion of flip-flops between modules increase the instruction latency compared to a non-pipeline processor. So, okay, so we're finished for our chapter for this week. I hope I can meet you again for the next chapter. Thank you for your support. Thank you for your subscription. Thank you for the likes. So hopefully, okay, continue again in next week. So stay safe, stay healthy, and take care. Assalamualaikum and good day.